question asks us to solve cos x equals 0.5. And I know if you put it in on your calculator, you'll just get a single answer. However, if you go back and think about what the cos graph looks like, it starts up at 1 and we get a complete cycle. And I'm going to work in radians here, up to 2 pi. Now that's only part of the graph, obviously, because it keeps on going. And it keeps going out in the negative x direction as well. Okay, so it oscillates between +1 and -1. And one way to look at trying to solve this is if we were to graph y equal cos x, which I've done here, and y equals 0.5, if I were to graph both of those, so here's 1, y equals 1 is up there, so 0.5 will be down here, so let's do it in another colour. So y equals 0.5 is going to be a straight line. And the solutions to this graph will be the simultaneous solutions for these two graphs. We've graphed y equals cos x, which is the black one. We've graphed y equals 0.5, the red one. So the solutions to this will be all these blue points where the two graphs intersect. So we don't just get one answer. Even though our calculator comes up with one answer, there are multiple solutions. If we go back to the unit circle, we know that we put our CAST, so cos is positive here and here. So it is positive in the fourth quadrant, cos, and it is positive there. It is negative in those two. So this point here, don't forget this goes up by pi on 2, so that's pi on 2. This will be pi, 3 pi on 2, and then that up there corresponds to 2 pi. So between 3 pi on 2 and 2 pi going back here is going to be that value there. And this value here is going to be somewhere in the first quadrant. All right, now 0.5 is a half, and we go back to our little special triangles where we've got pi on 3, pi on 6 in degrees, that's 60 and 30. This is it's an equilateral triangle cut in half, so that's 1, that's 2, that's √3. And so which angle in here has a cos of a half? Well, cos of pi on 3 will be equal to a half. So this point here will correspond, so x equals pi on 3. So you can see pi on 3 is going to be a little bit less here than pi on 2. And what's the relationship between that angle there and say this angle here? And you can see that the graph repeats itself every 2 pi. So that one is on the way down, so on the way down, so that one will be 2 pi. If we add 2 pi to that one, we'll get that one. So my next one is pi on 3 plus 2 pi. And then I'll get the next one on the way down over there. So, or pi on 3 plus 4 pi. Now, not only that, we've got those going that way, but we'll pick up this one down there. Now, that also differs by 2 pi. So we can go pi on 3 minus 2 pi. So instead of writing minus, we can go plus or minus 2 pi. And if we go over again, it'll be plus or minus 4 pi. And so we've only just picked up those. Now we've got to pick up these ones here. So that one there. So we've got x equals, now what's that angle there? Well, we've already said that it is in this quadrant, and it's the equivalent of going all the way around 2 pi and then coming back pi on 3. So this angle here, so this is pi on 3, and this one here will be 2 pi minus pi on 3. So to get that angle all the way around to there, we go all the way around 2 pi and come back pi on 3. And how do we work that out? Well, it's a bit like working with fractions. We've got to make them both over 3. So multiply top and bottom here by 3, and we get 6 pi on 3 minus pi on 3, which will be equal to 5 pi on 3. So this angle here corresponds to 5 pi on 3. So 5 pi on 3. Now once again, the same sort of thinking as we did before. To get this one here, it's just adding 2 pi. So it'll be 5 pi on 3 plus 2 pi, 5 pi on 3 plus 4 pi. So we should put dots there to indicate that it goes on. And just as we've gone in the positive direction, we can also pick up this one here by plus or minus. So that'll be minus 2 pi, plus or minus 2 pi, plus or minus 4 pi, etc. So the answer to this one is not a single answer, unless obviously we're given a domain for x. But as a general rule, we've got all those angles there. There are an infinite number of angles that have a cos of 0.5.